I'm going to cover three different kinds of equations in this video. One is on vector equations, another is on parametric equations, and then Cartesian equations. So I'm going to try to describe these three different kinds of equations by using this example of this toy car. So I have a toy car that starts at 3, -5, so I'm going to just draw our Cartesian grid at 1, 2, 3, and 1, 2, 3, 4, 5. This is where the car starts. And then I have this direction vector of 2 to the right and 4 up. 2 to the right and 4 up. So we have this line. So there isn't any vector. We just have this trajectory. We have a starting point and some trajectory. So at time 0, there is no vector. At time 1, we're going to have a certain vector. After 2 seconds, we'll have another vector. But the vector is going to be really dependent on how much time has passed. So I have this, because it's a line, for our vector equation, I'm going to use our slope-intercept form of y equals mx plus b. I always tell my students that the m stands for my move, and the b, that stands for my begin. Now the begin is usually my y-intercept, but in this case, our begin is this particular point here of the 3, -5. So I'm going to write my equation of this is a vector equation, so I have xy equals my move, that is my direction vector of 2, 4, and then we have some time t, and then plus my begin, which is 3, -5. Now this isn't usually the way that a vector equation is written. This is completely acceptable. You would get full points if you wrote your equation like this. But in standard form, we usually see a vector equation written like this, where we have xy equals 3, -5 plus t times 2, 4. That's usually how you see it. So I'm going to try to get in the habit of writing it this way throughout this lesson. So that is a vector equation. I also want to write a parametric, the parametric equations, and the parametric equations, or the parameter that we're using, is, in this particular case, it's time, and this is going to be time in terms of our variables of x and y. So our parametric equations are going to be x equals 3 plus 2t. We have our other parametric equation of y equals -5 plus 4t. So our parametric equations in this case are these two here. Now we also have a Cartesian equation, our Cartesian equation, and we can write it in terms of, Cartesian equation is an equation in terms of our x and y. So I'm going to take my parametric equation, I'm going to solve for t. So our first one I'm going to solve for t, so I have x minus 3, I'm going to divide by 2, that equals t. I also have, if I add 5 to both sides, that gives me y plus 5, and then I'm going to divide by 4, and that equals t. So I have two equations in terms of t. For my Cartesian equation, well, because t equals t, that gives me x minus 3 divided by 2 equals y plus 5 divided by 4. I'm now going to, I could stop here, I'd probably accept this, but I want to write this Cartesian equation in an acceptable form, one that people are familiar with. I can either write it in back to slope-intercept form, or I can write it in standard form. I'm just going to rewrite it in standard form. I'm going to multiply both sides by 4, which would eliminate the denominator, and then I'm going to multiply both sides by 2 to eliminate this denominator. That's going to give me 4 times x minus 3 equals 2 times y plus 5. I'm now going to distribute this 4, and I'll distribute the 2 as well, to get 4x minus 12 equals 2y plus 10. All right, at this point, I'll subtract 2y from both sides. That gives me 4x minus 2y, and I'm going to add 12 to both sides. That gives me 12 plus 10 gives me 22. So here is my Cartesian equation right here. So I'm going to do some examples. And here when we start out, this is 13b from your book. And it says here that it says describe each of the following lines, and these are just lines. Recall that these are lines. We don't really have a true direction. It says that we have a direction vector, but we don't really have a true direction. So we have this, and I want to rewrite this line in terms of a vector equation, a parametric equation, and a Cartesian equation. So, all right, so I have x, y, and that's going to equal my starting point here of 3, negative 4, and then I'm going to add that to my direction vector of 1, 4, and then put a t in front here. I think that's a little bit messy, but nevertheless, that is my vector equation. My parametric equations are going to be x equals 3 plus t, and y equals negative 4 plus 4t. If I want to write my Cartesian equation, I need to rewrite these equations in terms of t. That gives me x minus 3. I subtracted 3 from both sides. That gives me t. And then I'm going to add 4 to both sides. It gives me y plus 4, and then divide by 4 equals t. I have two equations in terms of t. So x minus 3 equals y plus 4 over 4. I'm going to solve, not really, I'm just going to rewrite this in standard form. I'm going to multiply both sides by 4. It gives me 4 times x minus 3 equals y plus 4. I'm going to distribute the 4 to get 4x minus 12 equals y plus 4. And then I'm going to subtract the y. That gives me 4x minus y equals, I'm going to add 12 to both sides. That gives me 12 plus 4. That gives me 16. So there you go. We have our Cartesian, that's our Cartesian equation. We have our parametric equations here, and we have our vector equation here. All right, I'm just going to do a couple of these, just jump around. It says the line that passes through this point 5, 2, which is perpendicular to 5, 2. So if it's perpendicular, we need to take the negative reciprocal of our vector here. So that's either going to be, it's either going to be 2, negative 5, or it's going to be negative 2, 5. Well, which one is it? Because we're talking about a line, it doesn't matter. We don't really have a direction. We just have to have some type of, slope. So, that would give us then, we have x, y equals 5 to our vector 5, well, this is a point. And then we're going to add it to our direction vector. Either one is fine, so t times 2, negative 5. We could, well, I think I've pretty much said it all, that we could either use either one of those would be acceptable because we're talking about a line. And I'm really not going to do the other ones. I don't think it's too time consuming, but I think you understand the concept of how to find the parametric equation and the Cartesian equation from this point here. All right, moving on. Part D, it says a line that passes through these 2 points. Well, if I have 2 points, I don't have a direction vector. How do you get a direction vector? Well, we take head minus tail, right? Head minus tail. Minus tail. And so it doesn't really matter, again, because we're talking about a line. I could have this A as the head or this B as my tail. So let's just do A to B. That would give me negative 3, 12, minus negative 1, 11. That gives me negative 3 plus 1, which gives me negative 2. And then 12 minus 11, that gives me 1. So I can use either one of these points. In fact, I'll do a couple of these equations anyway. I could also do B to A. That would just give me 2, negative 1. Is that right? Does that look right to you? So negative 1 minus negative 3 is going to give me 2. Yeah. So for my vector equation, I can have x, y equals 2, negative 1. No, I have to pick either one of these points. Negative 1, 11, plus t times 2, negative 1, or I could have said negative 3, 12, plus, let's do the other one, negative 2, 1, t. I'll just put the t back here, it doesn't really matter. But that is going to equal our xy. And then we could swap these out if we wanted to. So there's like 4 different ways we could write the same vector equation for part D, or for really for any of them. If you know multiple points along the line, then you're really looking at infinite vector equations then. All right, let's move on to number 2. So it says here, a line that passes through this point with a direction vector of 2, -1. Write a parametric equation. Well, let's start with our vector equation. So I have xy equals -1, 4 plus t times our direction vector of 2, -1. So our parametric equations are going to be x equals -1 plus 2t and y equals 4 minus t. Let's look at number 3. So it says, does 3, -2 lie on the line with this vector equation? Well, let's plug it in. So here's an example of a vector equation where we have the line is just r, where in fact, which is completely acceptable, but the way that you've seen it so far, I said that this r was our x, y components. So let's take these points and plug it in and see if we get the same value for t. If we get the same value for t, then we know that it lies on the line. If we get a different value for t, then it can't lie on the line. So I have 3, -2, and that equals 2, 1 plus t times our direction vector of 1, -3. Our first parametric equation, we have 3 equals 2 plus t. So t, in this case, equals 1. If I subtract 2 from both sides, I get 1. Well, what do we get down here? If I take that 1 and I plug it in here, do I get -2? So I have -2 equals 1 plus t is 1, according to what we just solved. We have 1 times -3. Well, 1 times -3 is -3, and -3 plus 1 is -2. So I have -2 equals -2. So yes, 3, -2 is on the line. Let's look at the next one. So it says here, K4 lies in the line with the parametric equation. I have these parametric equations here. So I want to know what K is. So this is X, K is my X value, and 4 is my Y value. I'm going to plug those values in here. So I have K equals 1 minus 2t. That's not really helpful. I have one equation and 2 unknowns. But if I take the y value and I plug it in here, then I have 4 equals 1 plus t. I subtract 1 from both sides, that gives me 3 equals t. Now I take this value here, that t equals 3, and I plug it in here, and I have 1 minus 2 times 3, which gives me 1 minus 6, which is going to give me -5. K equals -5. K equals -5. Okay, moving on. So let's see, let's look at number 4. So it says here that I have a line L has a vector equation of r equals 1, 5, and then our direction vector is -1, 3. And then I want to find it says locate the point on the line corresponding to t equals 1. Let's take that 1 and plug it in and find out. So if I have, so that's going to give me 1 plus 1, that gives me, so x is going to be 1 plus 1 times -1, and 1 times -1, or 1 times -1 is -1, and 1 minus 1 is going to give me 0, so that's 0. And then if I plug in for my y value, that's going to give me 5 plus 1, t is 1, so I have 1 times 3, that gives me 5 plus 3, which gives me 8. This gives me 8. So the location is at 0, 8. Explain why the direction of the line could also be, described as 1, -3. Well, it's because we're talking about a line. We're not talking about a direction. If I have this direction vector of 1 to the left and 3 up, and then we have this other direction vector of 1 to the right and 3 down, you can see that the slope is the same for both of these. Because the slope is the same for both of these, then we know that we can use either one of these for our direction vector. So it says, use your answer on A and B to write an alternative vector for L. Well, an alternative vector for L would be x, y equals, I don't know, we know this point here, so how about 0, 8, and then plus t times 1, negative 3. And if you want to, if you're so inclined, we could name it something else. Here's R, we could do Q, or M, or N. We could say that Q, this is our direction vector, or our vector equation, Q of 0, 8 plus t times the direction vector of 1, negative 3. Let's look at 5. 5, it says here, describe each of the following line using a vector equation and a parametric equation. It looks like we're looking at 3 dimensions. So it says a line parallel to 2, 1, 3. Well, if it's parallel, then that's our direction vector, which passes through 1, 3, negative 7. So we have our x, y, and z, and that equals our point of 1, 3, negative 7 plus t times t times the direction vector of 2, 1, 3. And there you go. And again, if you're so inclined, we could actually name it. We could say the line, the vector equation is, we'll call it R or something else here. We also have to write a parametric equation. So our parametric equations would be x equals 1 plus 2t, or y equals 3 plus t, or z equals negative 7 plus 3t. These are our parametric equations. All right, let's just do one more. I'll bounce down to here. It says a line parallel to the x-axis, which passes through negative 2, 2, and 1. All right, so if we're parallel to this, if we're parallel to the x-axis and we're going through this particular line, we have this point here at negative 2, 2, and 1, and we're parallel to x equals, parallel to the x-axis, then let's go ahead and just write out our vector equation. So that would give me our point, negative 2, 2, and 1, 2, and 1. And our direction vector is just going to be, because we're parallel, the only thing that matters here is our x value. Everything else is going to be 0. So I hope this was helpful. Have a wonderful day.